Have you ever wondered how much electricity your ChatGPT, Claude, Gemini, llama, or any other generative AI model consumes? Well, prepare for a jolt because the answer is a lot more than you'd expect. You see, AI GPU servers are the energy-guzzling giants of the digital world. They need more electricity than traditional computer CPU servers because they're constantly crunching massive amounts of data, learning, adapting, and producing enormous amounts of text, documents, images, music, and even movies. An AI GPU server can consume up to 100 times more electricity than a typical CPU-based server. Now let's add another layer to this. Picture an arms race, but instead of opposing nations, it's multiple AI generative models all competing to be the biggest, the fastest, and the best. You have ChatGPT and Gemini and Claude and llama and Mistral and many others. Each one is vying for the top spot, out-impressing each other, crunching ever more data, taking in more inputs, and cranking out higher quality outputs. This fierce competition pushes their electricity demands even higher, seemingly with no upper limits in sight. So, the simple act of asking ChatGPT for a meeting summary or asking DALL-E to generate an image of a cat riding on a unicorn triggers a series of events that consume a surprising amount of electricity. The thirst for power of these AI behemoths is turning out to be a shocking revelation. Presently, ChatGPT uses as much electricity every day as 180,000 US households. Think about that. ChatGPT alone consumes the electricity use of an entire city every day. And this only gets worse as ChatGPT and other large language models keep coming out with newer, bigger, and faster models to outcompete each other. Add to that the fact that more and more users over time are utilizing ChatGPT and similar tools for their work, home, and leisure as the adoption rate increases astronomically. There seems to be no limits. Now imagine this. You're a utility company, and you discover your biggest client is a data center running hundreds or even thousands of AI servers. Yes, that's right, folks. You've got an enormous power-hungry customer. The demand for electricity from AI data centers is skyrocketing, and it's causing quite the headache for utility companies. You see, AI servers are not your typical power sippers. These are heavy-duty, power-sucking machines that require a staggering amount of electricity to function. The surge in demand for AI technologies, coupled with the competition among large language models, is pushing the energy consumption of these data centers through the roof. What's worse, these power-hungry data centers also need up to an additional 50% more power just to run the air conditioners to cool the AI servers so they don't overheat and crash. This rapid increase in demand has left utility companies scrambling to keep up. The projected amount of electricity that AI data centers are expected to use in the near future is downright staggering. We're talking about numbers that equal the electricity consumption of several small countries. And why are utility companies falling behind, you ask? Well, the infrastructure just isn't there to support the massive power demands of these AI data centers. It's like trying to fill an Olympic-sized swimming pool with a mere garden hose. To put things into perspective, the utility industry's projected growth rate for electricity supply has been close to zero for the last 20 years. But the projected growth rate for AI electricity demand can double every few years. The bottom line is, AI technology is moving way faster than the utility industry, and the latter may not catch up to the skyrocketing power demands. Let's examine 6 possible solutions that are being tried to handle this dilemma. Number 1. Build more power resources at the utility companies. Several utilities are adding renewable energy sources such as solar, wind, and hydroelectric where it is applicable. There is a push for smaller nuclear power facilities, although that comes with its own host of controversies. Many utilities are also constructing additional natural gas facilities out of sheer necessity. It provides more continuous power than solar or wind. It is also probably the most cost-effective option for the short term. Number 2. Retain older fossil fuel resources. Several utilities have decided to reverse the retirement of aging coal and natural gas facilities. For them, they don't have much of a choice if they need to keep up with the tremendous surge of electricity demands. Anything it takes to keep things running for now. As an example, about 24 fossil fuel facilities from Kentucky to North Dakota that were set to retire have now been postponed and will be kept in operation. Sadly, this goes against many of the zero carbon emission goals that utilities have pledged, but then again, they don't have much alternatives. Number 3. Build more power-efficient chips, data centers, and cooling methods. One major concern is that AI servers generate 5 times more heat than traditional CPU servers, and as a result, AI servers often require 10 times more cooling per square foot, creating another big power issue for the data centers to solve. So instead of using just air conditioning, server manufacturers and data centers are adding other methods such as liquid cooling. Using this can bring down the heat, perhaps more efficiently and at lower costs than conventional air cooling. Other improvements can come from the power-hungry chips themselves. Newer generation of AI chips are constantly designed to pack in more processing, but with the benefit of using less power. And some people would argue that these newer power-efficient chips can reduce the overall demand on electricity, solving the shortage problem. However, this is actually a fallacy. AI chips using less power won't really solve the energy shortage problem. We just see more and more of these chips used everywhere, expanding the energy shortage problem over time, so there are limits as to how power-efficient chips can help. Number 4. Build more transmission capability. Many new data centers are being built in areas with vast spaces, typically non-residential. But these same areas often lack ample transmission lines for electricity due to lack of prior demand. Some people would argue that instead of a power shortage issue, you have an inadequate power grid issue. So the utility companies and authorities need to enhance the electricity transmission infrastructure and apply better grid management to make a smarter grid. It will take time to do, but it will help make sure that over time, electricity is more efficiently transmitted and distributed to where it is needed. Number 5. Build more backup power sources into data centers. Many data centers already have backup generators and batteries in case of emergency power outages. Perhaps these same data centers should add more of these resources to balance the greater power demand caused by the addition of AI servers. Not only should the utility companies scale up, but so should the data centers as well. And finally, number 6. Suspend the addition of new data centers. The state of Arizona recently put a temporary stop to adding new data centers onto the grid. The Arizona Public Service Authority needs to perform a case-by-case analysis on each data center connection request to make sure enough power, as well as sufficient transmission lines and substations, are available before contracts can be signed. In Ireland, the City of Dublin has placed a suspension on the development of additional data centers due to concerns of overstressing the power grid and causing potential blackouts. Singapore and the Netherlands had imposed similar bans as well. As power demand ramps up, more of these moratoriums may need to be imposed until the utilities can catch up. Unfortunately, it may take years for the utilities to do so. In conclusion, the growing electricity demands of AI data centers pose a significant challenge for both the AI industry and the utility companies that power them. If we look back at this earlier chart, we get the sense that these stakeholders are not really talking to each other, nor seriously planning the proper way forward. But this will have to change. As the competition for more powerful AI models continues, it will be crucial for all stakeholders to work together. We need to find sustainable solutions that can meet the energy needs of this transformative technology, while also protecting the integrity of the overall power grid. If we want enough power to generate, we need to ultimately cooperate. If you would like more continuing updates on these AI-related topics, please subscribe and support our YouTube channel. It helps us build a community, and feel free to leave comments or suggestions for other AI topics you are interested in. Until the next time.